Now let's move to the third equation, the equation for position-velocity relation. In the previous equation for velocity-time relation, we saw distance s is equal to area of the trapezium OABC. Now, by applying the formula for the area of trapezium, we get S is equal to OA plus BC upon 2 multiplied by OC. By substituting the value of OA is equal to U, BC is equal to V and OC is equal to T, we get S is equal to U plus V upon 2 multiplied by T. From the velocity-time relation, we know T is equal to V minus U upon A. By using the value of T, we can write the distance as S is equal to V plus U upon 2 multiplied by V minus U upon A, which is equal to U plus V multiplied by V minus U upon 2A, which is equal to V square minus U square upon 2A. 2AS is equal to V square minus U square.